ever wondered why you can't taste when you have a cold? Well, we are going to tell you why. Hi, my name is Allison.
My name is Sydnie, and we are from Calhoun.
We are going to talk to you about the olfactory area, the gustatory system, the nose, the tongue, and the connection between the senses of taste and smell.
First is the olfactory area. The olfactory area is a region just underneath the brain. It is packed with millions of small nasal cells. An important part of identifying flavors and foods is the identification of odors. Molecules of the air enter the nose, where they combine with receptors. An average person can discover 4,000 to 10,000 is made up of more than one type of molecule.
Next is the gustatory system. The gustatory system pertains to the sense of taste. The system has two main functions. They are recognizing taste and identifying flavors. The identification of taste begins in the taste pore, which is the opening of the taste bud. In the taste pore, molecules interact with receptor cells. After that, nerves leading to the taste bud to the tongue are stimulated in buds that react with chemicals in the food. Taste buds have a limited ability to detect flavor.
Next part of our presentation is the nose. The nose not only takes in air, but also bacteria, dust and dirt. Mucus. Mucus is an air fluid. It traps dust and microbes in the air. The nose makes a pint of mucus each day. This is mostly good that if the mucus in the nasal passage is too thick, the other molecules to receptor cells. Molecules then get trapped in the mouth because the pathway to olfactory receptor cells has been blocked off by mucus.
The tongue is one of the most active and mobile muscles in the body. The tongue can move in many different directions, up and down, side to side, in circles, and it can even curl up. The tongue fills up most of the bottom of the mouth because it is connected to the epiglottis. The taste buds respond to four basic flavors: sweet, salty, sour, and bitter. Different areas of the tongue identify different flavors. The tip of the tongue is most sensitive to sweetness and saltiness. The middle is most sensitive to sourness, and the back is most sensitive to bitterness.
Now we're going to talk about the connection between taste and smell. Taste and smell are the most developed of the five senses. The sense of smell greatly increases to the ability to taste. When the food is put in the mouth, chemicals from the food is released into the nasal passage. Odor molecules traveling between the nose and the mouth to olfactory receptor cells. When we have a cold, mucus blocks the access of odor molecules. The brain does not receive a signal identifying the flavor, so everything will taste the same.
We designed an experiment to prove that the ability to smell does really influence taste. We used 5 flavors of Jell-O so the volunteers could detect the difference in texture. The first step in our experiment was to prepare the Jell-O. Then we gathered 20 test subjects. We covered their eyes with cover goggles so they couldn't see and plugged their noses with nose plugs. We asked the volunteers to sample one flavor of Jell-O and asked them to try to guess which flavor of Jell-O they were tasting, if they could taste anything at all. We recorded what their answer was. We gave them a drink of water to rinse the flavor out of their mouth. And then we repeated the same process with the 4 remaining Jell-O flavors. Then we removed the nose plugs and asked the same volunteer to taste all 5 flavors of Jell-O again, and again asked them to guess which flavor of Jell-O they were tasting, if they could taste anything at all. We recorded their answers, and then the final step was to repeat the whole process with noses plugged and unplugged with the remaining volunteers.
Our results prove that the ability to smell does influence the taste. The number of volunteers that guessed the texture when the nose was plugged was an average of 3, and the number of volunteers that guessed incorrectly when their noses were unplugged was 17. And the number that was guessed correctly when their noses were unplugged was an average of 12, and the people that guessed it incorrect when their noses were unplugged was an average of 7.
We drew 4 conclusions from this experiment. The first conclusion was that the senses of taste and smell are greatly related. The second conclusion is that if the nasal passage is blocked off, flavors cannot be detected. The third conclusion is that the brain won't receive a signal identifying the odor if the access of odor molecules to the receptor cells is limited. And the fourth and final conclusion we drew is that 58% of our volunteers couldn't guess the correct flavor of Jell-O when we had their noses plugged.
This concludes our presentation. Questions?
again, I would hope that you'd ask any questions. Tell us why you got involved with this.
Okay, well the question was, why did we get involved with this topic? And mostly because we'd always wondered why we had colds. You couldn't really taste foods that you were eating, so we were just curious whether they really were great degraded. And I always heard that if you don't like food, you should plug your nose and eat it because it goes down faster. So I was curious if that actually works. So we just kind of discussed it and went from there. Yeah.
What flavors did, maybe I missed it, but what flavors did you use in your experiment?
The question was, what flavor did we use in our experiment? We used ones like lemon, lime, and cherry, and watermelon, and grape, and peach. Yeah, peach.
Are there any other questions?
Was any flavor, did you see a difference between the flavors, one that was stronger?
Well, the question was whether any flavor was stronger, just with tasting. And a lot of people could guess cherry, right? And then there was a lot of confusion between lemon and lime. So I think if we were to do this again, we'd pick flavors that weren't so much alike, so similar. So I guess that would make it easier for them to guess which flavor they were tasting. Any others?
Of your conclusions, was there one that surprised you?
I guess really the only one that surprised us was that there was only 58% of our volunteers, just more than half. We expected there to be a lot more that couldn't, but our nose plugs, different people's noses being different, I think they're not fully plugged with depending on, who you're testing. So maybe more consistency with what we were doing would have helped our results better, but we were kind of surprised that it was so few people. We expected a lot more to not be able to taste as well. Any other questions?
Thank you.